issues, but hopefully we overcame that. Good afternoon, everyone. We have this acceleration stage, AI RAN, in action, and what we're trying to do here, we had discussions on the main stage this morning. We had the Open RAN breakout session. We had the Open OOPT breakout sessions as well. And what we discussed is everything to do about AI in RAN. And what we would really like to see today is to deep dive and see how we can translate those concepts of AI in real networks. We don't want to be discussing any hypes or we don't want to overpromise anything, but what we just want to see the actual concepts of AI being deployed within RAN. It's been discussed that AI will optimize the RAN. Is this true? And so let's welcome our panelists. We have Tanveer Alam from DeepSig. We have Siddhar Rajagopal from Inoya Technologies. Yeah, you can just sit here. Neil Wu from Shanghua Technical Laboratories, and we have Raymond Dolan from Cohere Technologies. So thank you very much for joining me here.
Okay.
Okay, so you've all have your products on AI. You're in the telecom on the RAN space. Some are startups, some are more mature. Some of them have been in the market for some time. We heard on the main stage this morning and on the different breakout sessions how AI can actually optimize the RAN. Is it true or not? Maybe I can start with you, Raymond. Raymond, you've got your universal spectrum multiplier. It improves capacity. It uses intelligence pairing recommendations on multi-user MIMO. So tell us more about your USM and how do you think how AI is actually defining something, like improving the spectrum efficiency of the operators.
Thanks, Abdel. So yeah, I'm here on behalf of Cohere Technologies. We have really two products to market. One is an air interface, which is a 6G story. We'll leave that for another time. The focus today is on USM, which we call a universal spectrum multiplier. It is born in the radar domain, so it listens to reference symbols that are in every standard. So we're truly universal, so it works at 4G, 5G, anything, even Wi-Fi. And leveraging those reference symbols, we reveal the geometry of the environment. So in this case, we reveal the room, right? Parts of the room are moving, parts of the room are not. We would map the reflective environment, and then we would know based on that reflective environment how to establish channel state to every user. So think of channel state as the fundamental foundation of all communication in the radio world, at least. And we establish channel state at scale with every user in this environment, and now the brain of the base station knows how to transmit to every user efficiently, right? So if you want to call that AI, I'm fine with that. When it scales to massive capacity, when it scales to full mobility, when it scales to any waveform, when it scales to thousands and thousands of users, and then when it moves from the edge of the network at the base station to the data center, because when we reveal the geometry, we actually know that channel state for 100 milliseconds or more, depending on whether the user moves. So think of it as, people in the AI world use this notion of tokenization. We have tokenized the foundation of radio communications, which is channel state. So once you tokenize channel state, you now revolutionize the wireless industry. Last week, NVIDIA announced a $1 billion investment in Nokia, and Nokia and NVIDIA announced that they're going to move the world to a GPU-based architecture, which is AI RAN, and the first two workloads they're going to move is beamforming and scheduling. That's what Cohere does. So hopefully that's a good answer to your question.
Yeah, absolutely. And just to follow up quickly on this, what kind of complexity do you add to the network? You don't need to add anything on the UE side. I get it. What about the actual RAN side? Where do you plug in your device?
now I'm going to make your head hurt.
Yeah.
We lower the complexity of the network at the same time that we tokenize the beamforming and scheduling capacity. And the reason is, instead of looking through phase, amplitude, angle of arrival, and all of the complexities associated with today's world, which are massively complicated and they don't scale, we're looking at the geometry of the user. And once you move to the geometry of the user, your frequency independent, time persistent. And so once we establish channel state, we establish that channel state persistently across all frequency. So ironically, we reduce complexity while we address value.
Okay.
Yep.
I know that's going to make your head hurt. The only reason that makes sense is because we're actually doing that in the real world with operators that are here today, and you can talk to some of them.
I'll come to that question later on. Maybe I can go to Tanveer. Tanveer, you do optimization using deep language, deep intelligence within the networks. Tell us more about that.
So basically, we have been using algorithmically doing this forever, right? We have hundreds of years of equations that basically map out the channel and physically look at, reflectivity, corner cases, and so on, right? But in the newer world, where we have so many signals and it's a highly congested environment, we can probably tweak out much more, right, with spectrum efficiency by using some kind of AI learning. And that's exactly what we are trying to do with DeepSig, with one of our products called OmniFi, which is the layer 1 optimization. And so we're basically using techniques like ray tracing, as well as looking at pilotless signals, right? Similar to what Ray was talking about, but more on the OFDM side as well. And then basically creating a very good model between the transmitter and the receiver, so it actually understands, even on dynamically, real time, and it can adjust to things real time because things are never static, right? Equations are static from the past, right? But now as we go into the future, we must rely on much more dynamic tools to basically solve these equations. But that's exactly what deep learning does, is basically takes a neural approach rather than an algorithmic approach to solving these problems.
Okay, thank you very much. Maybe Neil,
Yes.
in Changhua,
Zhonghua Telecom, yeah.
yes, sorry.
No worries.
In the laboratories, you use AI to test, and you've got energy efficiencies
Exactly.
and frameworks. Tell us more about that.
There are energy efficiency, right? Okay. Hi guys, I'm from the Zhonghua Telecom lab. So now I lead the Open RAN team for Zhonghua Telecom. Okay, so basically I feel just like we have so many discussions from panelists about the spectrum efficiency. So now we know that for operators, the spectrum efficiency is super important because we have so many resources about the spectrum. So if we can gain more throughput from the spectrum, then in price that we can gain the benefit without change or do more investment in the spectrum, right? Another thing is about our new topic, energy efficiency. Energy efficiency is also another topic relative to the spectrum efficiency. So basically, for the same spectrum, we want to make use of the spectrum, but because natively the mobile network, they will cost so many energies. So especially if we deploy the Open RAN or the legacy RAN in massive scale, then you will encounter the power, the energy will be consumed by the bigger scale deployment. So in this case, we start our investigation from 2023 about how can we deploy energy saving the software in our SMO or even in the rig. And now we also have some achievement. The first method is we using the SMO as our best platform. So in this platform, we have a very basic scheduling algorithm, but it's not based on AI. So scheduling algorithm will make use the different frequency coverage for the area. So basically for maybe in the midnight, usually users didn't use the network in midnight, right? So in this case, we will have such a scheduling algorithm. So we can turn off the high frequency, like N78 or even higher frequency to saving the power, especially for a massive MIMO. It's a super power cost. in our network. And recently, we also designed a new architecture that's based on our RIC platform. Because RIC, a RAN intelligent controller, natively is also a very high cost investment in current stage, I believe so. So in our design, we use a SMO to redefine the R1 interface in northbound. So we can make use the RFs as an energy saving to do a deployment with our existing the SMO platform. So with the O1 interface and with also the legacy legacy vendors interface, like Ericsson or Nokia, we can use such RFs to control dynamically for providing a better energy efficiency.
Okay, very good. You've mentioned massive MIMOs or MIMO streams, switching off MIMO streams, power amplifiers, switching off different layers.
That's different stage.
Yeah, what about ASM, advanced sleep mode, or on the O cloud side? Is there any areas in that space?
Oh, okay. Yes, just like you mentioned, because for the massive MIMO, it have different stage. You can turn off the power. Now, the first one is about maybe turn off the power amplifier. And next stage, you can ask you to deep sleep. And later, you can simply shut down all the massive MIMO, right? Yes. So for a different stage, we use the SMO to control, depend on the user quantities. So maybe if the users, they have so many limited, because some users still using the network. So we can observe there's still some device still working on the coverage area. In this case, we'll simply just minimize the MIMO scale. Okay. So maybe originally it's 64 TR. We'll minimize it to 16 TR in this case. And if we found that, okay, basically there are no device working in this area, we simply just can shut down, make the massive MIMO unit into shutdown mode. So later we can wake it up. Yes.
Excellent. Thank you very much. Sidar, you've got in Oya Technologies, you've got a niche idea on using co-pilots to debug, making RAN configuration simpler, using small language models instead of LLMs at the edge. Yeah, tell us more about that. And I think you have a slide on this.
Yep.
No, thank you for the introduction, and thank you for inviting me to the panel today. Sridhar Rajgopal from Oya Technologies. So actually this whole integration, I mean, we have been discussing about the REC and everything else today in terms of optimization. But I think where we found the real issue is, I mean, a lot of the techniques where AI is being introduced in the network, I mean, these are all risky techniques in the sense it has not, it's not a mature solution yet. So when you're making a change to the network, like it's an intrusive change to the network because you're actually tuning some configuration parameters, making some changes, and there is always a doubt among operators whether this is a mature technology or not. Yep. So we found that instead of applying AI to something that is, I would say, almost working at the heart of the operations of a network, applying AI to a non-intrusive part, like looking at it from a test and measurement angle, where you're just probing things and looking at information and trying to get some root cause analysis, is a much safer way of introducing AI into an operator's network. And that is how we came into Oya Technologies. And one of the main problem areas we focused on is where is the operator spending money? So if you look at it, of course, I mean, we are trying to do everything remotely in software, but RAN is a very big portion of an operator's spend. And many times as we deploy cell sites, there are problems that are not easily identified I would say, at a 5-15-minute KPI interval that you typically get. And a lot of these are like transient issues, like interference, like GPS connectivity, and things like that are very hard to debug. So what we have been focusing on is how do you enable an operator to minimize these site visits? I'm not saying you'll never have to visit a site, but can you put an AI agent sitting on the site that can actually help you identify a lot of these issues? Maybe you may not be able to do a deep analysis on it, but maybe you can capture some of the key issues, and maybe during a maintenance window or something like that, offload it and do a deeper analysis offline, and then you can get all the network information and use all your RApps and XApps to kind of get more insights into what could actually be happening. And so that is what we have been working on. Now, the key issue here is, we all talk about AI, we all talk about large language models and how an operator can use all this to get a lot of insights into their network at a global level. But obviously, when you're working at a cell site and these, I mean, you have to work with a very small form factor, and you probably get a couple of cores where you can actually put your solution. Now we have it working on a mini PC, and where we can do some kind of light touch identification of problems without having to put a lot of compute resources to actually get this kind of insights. And this is where I think we need to have small language models which are very customized to that specific use case.
Right.
And so we can make it really small, and so it's working just on that. So it doesn't need to know what is the capital of France. It only needs to know, this is the signal, this is what it is supposed to do. And so we have pre-trained our models to just focus on that problem. And the best thing of all is it's free of cost because it's all open source. You don't have to pay tokens to OpenAI. You don't have to pay tokens to Anthropic. So this is all localized, open source, pre-trained models, customized for that application. And that is where we think there's a lot of value to be gotten for an operator.
But how do you feed it with updates and new information and new specs?
Yeah, so the way it actually works is anytime a new issue or something, because it's again AI, so it's actually learning. So anytime it's trying to debug issues that's happening at the site and giving you some information that you can. Now, obviously, there can be a new issue it has never encountered before. So obviously, it notes that, and then, as I said, during a maintenance window or something like that, there is some information that is sent to a centralized cloud and says, oh, it's a new issue. Then the centralized cloud now looks, okay, there are so many other sites, so it's trying to correlate all that information, whether this issue has been seen in some other place. And so it's actually whenever there is a substantial update, now it learns from everybody else and then pushes all those updates back to the small language model.
Okay.
So that's how you do the model training and updates.
Okay, excellent. Thank you very much. If I go to you, Tanvir, you have a slide here as well. Tell us, and this is going to be for all of the panelists, about any POCs, any deployments, any lab testings that you would like to share the results from what you've just discussed.
I think we just won the U.S. government Okudu funding for Future G. So we are trying with SRS RAN to kind of make that happen as well. One of the main things that we are seeing is that with AI RAN is basically the lack of reference, right? Reference designs and how to kind of target how much, what is going to move the needle for operators, right? And what is the KPIs for which the needle needs to be moved. So that's actually what this investment with NVIDIA and Nokia and such investments in the future would allow us to create these references where we know what to target, right? In terms of how much improvement is better on the physical layer, right? Right now we're kind of flying a little bit blind, and obviously we work with operators to have certain agreements for that. So yeah, I think we have two products. One is the Neural Phi, and the other one is basically scanning the RF frequencies for any kind of interference and labeling them using AI. We have a work with the Department of Defense to do that with the US. And those two products are basically kind of complementary in a way that we can actually use it in a commercial setting where also, or even a private 5G where you're able to sense the environment as well and see if there's anything needs to be mitigated, right? If there's interference, and we can basically figure out what that interference is, and then take care of it on the neural side as well to kind of switch the modulation, switch the frequencies, and so on.
Thank you for that. If I go to you, Raymond, tell us more on any deployments or any engagements you had with operators or enterprises.
So we are focused on the operator community, and we've announced a series of tests with Deutsche Telekom in 2020, Vodafone in 2021, Telstra in 22, Bell in 23, Vodafone in 24, Bell now in 25. We just did a podcast with some folks from Bell Canada and Vodafone to talk about where they are. So we're getting very, very close to commercial deployment of our USM. We've ported our solution to one of the largest RAN suppliers in the world. Which my guess is that'll be announced at MWC, and we'll probably do some things there. I want to pick up on what Sridhar said when you decided, rather than go to the heart of the network, you're in the safe zone of the peripheral of the network. We're at the heart of the network, right? We've said at Cohere, we're going to transform the very control plane of the wireless network, right? The channel state information and the scheduling in a spatial domain of the user, right? That's like literally introducing AI into open heart surgery, right?
That's right.
I mean, go big or go home, right?
That's right. No, I didn't mean that we
No,
shouldn't apply AI to the heart of the network. I just mentioned that that's the first. I mean, it's like a tree. You take the low-hanging fruits first, and then
Go for the low-hanging fruit. We're going big or we're going home,
That's
right?
right.
So this is an industry that deserves someone to come in and transform the heart of the network. We are now jointly scheduling with one of the largest RAN players in the world. We're adding significant value. We're generally triangulating with operators on announcing things like 50% improvement. Imagine you can do 50% better with your assets. And imagine an industry that spectrum assets are $1 trillion globally.
Yeah.
Imagine an industry that has $1 trillion of handsets, and I just basically use $250 times 4 billion. It's actually more than that in both cases.
I completely.
Imagine $500 billion of network assets, all of which that can be made 50% better in software, right? So if the open heart surgery takes a little longer than you think, it's worth it.
That's right.
So most of the operators are announcing that the closer they get to commercial service with us, the more confident that they get in the 50% improvement. That 50% improvement is in 4TR. It scales almost linearly as you go to 8, 16, 32, 64TR. Our 4TR solution is already better than anyone's 64TR solution.
Cool.
Let me say that again. Our 4TR solution is already better than anyone's 64TR solution. And then we have a waveform that is a completely configurable waveform, right? So while you're making OFDM better, and I had been the co-founder of Flarion Technologies, pioneering OFDM in a CDMA world, we're pioneering OTFS in an OFDM world. So here's what we'll say about OTFS. It's the mother waveform from which all of the waveforms are created. So we already render 4G, we already render 5G, and we will render whatever comes out of 3GPP for 6G. But we will also do things beyond that. So in an AI world, we're given an open heart transplant to the existing architecture. It's scary. Not everyone wants to do it. Not every vendor wants their heart opened. But the ones that have opened their heart have generated 50% better performance when they partner with us. So I like our odds, but it is going to take a while because, and I commend everyone that's operating with the low-hanging fruit because frankly, you should go after everything. But it's great because we get to compare the folks that are doing things in a non-real-time space are going to make networks better. Why not turn things off when they're not used? But I would say, why not make them better when they are used, right? So if you can turn things off when they're idle, that's awesome. But why not make them more spectrally efficient, more power efficient when they're on? So that's really what we're doing. And so I would imagine, well, let me just say this. I'll lay a marker out. By next year, MWC will announce some commercial relationships with at least one operator, probably multiple operators.
Okay, that's great news. I think the business case is there. As long as the technology can be proven,
And if
it's a no-brainer.
If not, we should just go away and be a footnote to history, right?
I hope not, but yeah.
Yeah, I hope not too.
So we'll looking forward for the news on MWC next year. That's almost in 4 months' time, right?
Coming up.
So it's down the line.
We're very close.
Very good.
Very good.
Neil, yes.
Yes.
What kind of engagements do you have with operators that you could like to share?
Okay, you mean about the engagement?
Yes,
Okay, with other vendors,
with the operators
with the other operators. Okay.
or vendors. Yeah.
Or vendors, yes. Okay.
But if you can do it in 2 minutes.
Okay.
Okay, and then 2 minutes, and then I will just
Okay.
have a final 1 minute question
Okay.
for you all.
Okay. Currently, right, because Chunghwa Telecom naturally is the only one operator that have commitment about the Open RAN in Taiwan.
Okay.
So for the Open RAN community, currently we are more like a solo monolith. So we don't have any other any other operators are for the engagement. Yes, but because we have more connections with other foreign operators, like NT Docomo, and even like the Deutsche Telekom and Orange and other operators. So we always keep in anything that can be updated in the Orient lines. Yeah. So yes, so basically we may focus more on this standard definition in the Orient lines. Yes, this is currently with the engagement we have for this moment.
Yeah. Yep. Excellent, thank you very much.
Yep.
Sidar?
Yeah, so we have been discussing this with multiple operators, and I see a lot of interest. I think one of the challenges to make this successful is, again, the training and the data, and that has been well discussed in this forum, that as how important data is for any kind of AI work. But I would actually say it's actually a little bit, if you look at the second level of information that you need, see, it's one thing to have data from an operator, but
right.
And you can label it as, but the question is what type of data and how much data, and then who maintains the data, because again, there are different operators, there may be different people. So I think these are the kind of things that I think need more discussion in a forum like TIP. And this is where I think all of us can come together, because it's not just, I mean, everybody can say, I want data from an operator in order to make AI work. But I think the question is, again, what type of data, who's going to maintain the data, who's going to police the data, and who's going to say this is the golden step, and if it works, everything is work for everybody. And I know TIP is looking at badges and other stuff as well, and I think this is an important thing to consider as you go forward.
Yep.
Yeah, excellent. One last question then. In a minute, please, each. What would you like for the to see in the operators network to be able to deploy your solution? We heard today that 6G will be AI native.
Yep.
I heard it before from one of the industry veterans that 6G will be AI native, just like 5G is cloud native, meaning that will probably take another decade or more to happen. So for your products to be integrated in the operators network, what would you like to see in the network? In a minute, please.
Yeah, obviously, and I think I referred to it earlier as basically some of the problems that we have in the industry here in terms of what to target in terms of the KPI. But the other thing I would say is basically we want the system to be open. And obviously as many open systems as possible, because to create competition as well as create other innovators to bring in. So our Okudu project kind of is run by the Linux Foundation, so they'll have other outside world entities to bring in resources for programming for that as well. And so I think those are the main two things, is basically reference as well as openness. Those two will
Reference and openness.
Yes.
I like that.
Okay.
Sidar?
No, I agree with him. I think, but I would say that there have been some work from like the government, like the US government. We have this NTIA awards for the NOFO funding for open. There are Open RAN labs. I mean, so there's a lot of work going on. But I think what is missing is, again, the fact that how can you say this is, if I get data from this kind of places, how can I say this is a golden set, or again coming back to the same. So I think we really need to have a way of identifying that from an operator perspective, if they can come up with a reference solution that somebody says, if I go and test my stuff here, I mean, it gets some kind of stamp that this is going to work in their network. And I think we have been discussing this digital twins and other kind of ways to kind of do this better. But I think coming up with something that can be stamped and can be said, if you do it here, it's going to work, and we are happy with that result, I think that's the challenge.
Perfect. What would you like to see in your own network?
Okay, in our own network. Okay, I feel that the power of agentic AI is almost like a future, greater future in our network, especially in the SMO sense.
Okay.
Yes, but I have to mention that maybe we have faced a great challenge, because we just mentioned, no matter in channel estimation, no matter in this power saving or spectrum efficiency, data exposure is always a challenge for the operators, because operators usually tend to be conservative about exposure in their data. So this will become like a barrier for the vendors to making progress in adapting the AI in their network. So maybe later, no matter the NTIA, no matter the government, or no matter the standardization like Orient Lines or TIP, maybe you can define a new standardization. How can we exposure the data and without compromise any privacy from the operators?
That's definitely a great suggestion. We'll be looking forward for it. Ray, Raymond, sorry.
No
Is
worries.
the operators ready for your product, or would you see some?
Yes.
Would you like to see some
So
changes?
yes is ready, but I'll piggyback open for sure. And not just open for interfaces, open for innovation. Second is embrace the cloud as fast as you can. If you look around, the most profitable service providers in the world are cloud service providers. The fear of cloud and wireless needs to go away. Invest in backhaul, because once you invest in backhaul, you can decide where you want the parts of your architecture to be. And it turns out that the further you put your scheduler into the network, the wider the scheduler looks at the network. Wireless is an interference-limited network. Half the interference is within a base station, half the interference is between base stations. We're only dealing with half of the problem right now. If we can open the architecture and put the aperture back at the data center,
Okay.
the network capacity will double overnight.
So that's not our problem, right?
Right. So open, invest in backhaul, and microservices like the cloud, and you'll see the wireless operators become massively more profitable for the growth ahead.
Yeah, excellent. So openness, invest in cloud, and invest in backhaul. I think key takeaways here.
Yeah.
Thank you very much for this panel.